Hi, this is Corrosion and Civil Engineering by Sam Bell, Jaden Cardenas, Carson Cervenka, and Adrian Areza.
Corrosion has serious effects on coastal infrastructure, and that's why we chose to do this project on corrosion because it's one of the most common issues that face civil engineering, and it often affects pieces of infrastructure such as bridges, boats, and just pretty much anything made of metal. And it has to do with chemistry because corrosion is a chemical process. As metallic iron oxidizes, it turns into iron 2, iron 3 oxide. It flakes away, exposes more metal, and the cycle repeats until the metal just eaten away.
So there are four members in our group: Jaden Cardenas, me, Sam Bell, Adrian Areza, and Carson Cervenka. I'm the team manager. The team facilitator is Carson Cervenka. The product manager is Adrian Areza, and the research facilitator is Sam Bell. So our main struggle was communication and setting up times properly every week to show up and get the work done. But we fixed this by just agreeing to meet at the same time every week, so we wouldn't have to worry about setting up times and getting one together. So initially we agreed on doing corrosion, but we also talked about marine life and methods to reduce pollution. That is, implementing certain methods to prevent pollution from harming the ecosystem and keep marine life away from potentially harming structures. And we ended up choosing corrosion because as civil engineers, it's our job to promote long-lasting structures, and everything is subject to corrosion.
Causes of corrosion. Corrosion is actually the byproduct of other metals attempting to reach a Moore's table state by bonding with oxygen. The speed of corrosion is dependent on multiple factors, such as moisture content, salt content, temperature, and oxygen content. Most metals will oxidize given enough time. Some are quicker than others. As the metal oxidizes, it flakes off, exposing more metal, which further oxidizes. The cycle repeats until a hole is formed into the metal.
Corrosion prevention. There are multiple ways to fight against corrosion, each with their own advantages, disadvantages. In most cases, corrosion is inevitable. However, there are multiple ways to slow the process with certain methods. Small list of these include galvanization, using coatings, alloyed metals, and cathodic protection. Coating uses materials such as plastic paint or wax as a physical barrier from corrosion and is the most cost-effective method.
So for the first real-world image, we have the SSS Selma, which has been in saltwater since 1920, and this is our first example of prolonged corrosion. As you can see, it's it's not a ship anymore. They're very clear in the image. Rust has formed massive holes in the ship's superstructure. So
Another example of severe corrosion is the USS Texas, which was not properly maintained, and as a result, the entire torpedo blisters needed replacement, which in the image you can see the whole ship looks like a quilt from a patchwork of repairs. And the corrosion was so severe, the vessel was crippled and had to be towed into port. And the structural integrity will never be the same. And that is one of the major consequences of corrosion. If it's not properly maintained, it can cripple a vessel and cause millions of dollars worth of repairs.
Another real-world image is the USS Stewart. This is an example of proper maintenance. Unlike the USS Texas, the Stewart was kept above the waterline on dry land. Its hull was painted, and it was routinely inspected for structural integrity. Through proper maintenance, it is possible to preserve a structure for decades, and the USS Stewart is evidence.
Addressing the problem. The largest organization for managing corrosion is the Federal Highway Administration, which oversees all infrastructure. Their job is to inspect infrastructure and address corrosion when necessary. They are in charge of bridge maintenance as well.
The effects on marine ecosystem. I mean, while marine life can be a nuisance to structures, animals such as barnacles will typically latch on to structures and they'll create an ecosystem as the barnacles attract other animals which prey on them, and you end up with a small ecosystem around these structures. So in a way, these structures can be good for marine life, even if they aren't necessarily good for the structure. And this is just our works cited, and that's all. Thank you for watching.